LabTech Engineering have been manufacturing laboratory-sized blow molding machines for quite some years now. Been making single layer, two layer and 3-layer bottles like this. And this has a capacity of 125 cc's. But now we've made a larger model of the blow molding machine, which also can make single layer, 2-layer and 3-layer. And it's twice the size of the older bottle. So this is 250 cc, whereas this is 125 cc. So here's the blow molding machine behind me. And we start off by just having a look at the extruders. We have two extruders here, LabTech extruders, a 25 millimeter and a 20 millimeter. They both contain mixing screws. And they each have their own control panel where we can set the various temperatures. We're running HDPE here, so we're running around about 180, 185 degrees C. So this top row of instruments are controlling the temperatures, set temperature and actual temperature. We have an instrument for measuring the load on the motor, and also the RPM of the screw. We have power on, off, screw start, screw stop. And we also have this sort of central control unit where we can set the temperatures of the connecting pipes from the extruder to the die, here and here. And down here we can control the screw temperatures of the extruders apart from the control panels on the extruder. So if we press both of those, we can set the screw speed on one extruder, set the screw speed on the other extruder. For example, if they're different speeds, we can press sync for the master controller, and by scrolling up or down, these will move in proportion or in ratio to the original settings. So we can control the screw speeds from here. And this is the blow molding attachment. It's similar in design to our older blow molding machines, but a little larger for the mold and the die. The die is here, and we're making 2-layer film, so we have 2 extruders, and the parison comes down here. We have a cutting blade that cuts the parison when it's of the correct length. This is the mold, which opens and closes, so this will swing up, close around, and we cut off the parison. The mold comes down, closed, and then the blow pin goes down to blow the parison into the shape of a bubble. So this machine, this attachment, is only single parison and single blow station. This is the blow pin. The blow pin is in here, so this can go up and down, and it's operated pneumatically, and we can control the stroke of the pin using there's a lock nut and an adjusting nut up here, so that the pin, when it comes down, it hits the striker plate, which is an insert here, and it virtually cuts off the top of the parison. And the bottom of the parison is cut off by the pinch insert on the bottom of the mold. If a customer wants their particular logo on the bottle, we can have it machined into the cavity of the mold. And after the parison is blown into a bubble, the mold opens and the blow pin rises, and the molding is still on the pin, and as the pin rises, this is a stripper plate which strips off the bottle, and it drops down into the chute, and there's a bin around the corner. And here's the control panel for the blow molding attachment. We have a touch screen up here, but let me explain these instruments first. We have temperature controllers for the die. The die, by the way, is a spiral type mold, which have parts nested so that we have two spirals, one from one extruder and one from another extruder, to form the two layers in this case. And another temperature controller here for the bottom of the die. Now we can run this line either in manual mode. This sort of orange light comes on in manual mode, semi-automatic, blue, and fully automatic, green. Manual mode, that's used mainly for setting up when you have a new mold or you're changing a blow pin and you don't want to run a whole molding cycle. You can operate, you can do the mold open and mold closed, carriage up or carriage down, everything manual, blow pin down, blow pin up. That's when we're on manual setting. Semi-automatic means that you've made all your settings and you press the start button and we will get a molding cycle, mold close, goes up, pin goes in and cuts, and the whole cycle goes. After one cycle, the machine will stop. And if everything is okay, we can switch over to fully automatic, where the machine will run cycle after cycle after cycle without any breaks. And this yellow one is manual cutting of the parison. If we just press this, you get a quick cut of the parison manually. Power on, power off. Reset if we hit an emergency stop, and it brings the blow pin up and the mold open and in the down position when we press the reset. These two gauges here, this is for the setting. We can set here the blow pressure, the air pressure for blowing the parison inside the mold to make the bubble. That's the setting that we will use for blowing the parison, and this will show you exactly what's happening during the cycle. So this will always be at this setting, and there's no air blowing now, so this is on 0. When the parison is blown, this will also go up and give the same reading as this. So this can be controlled here. And this is the touch screen with main screen, display screen, timer setting, and check error. So this is the main screen. Press display screen, and we get this window. We can either have blow pin first, where the blow pin goes into the mold before blowing, or we can have blowing first, where we get blowing before the pin actually gets into the mold. So we normally run blow pin first. Yeah, blow pin first. Hot cutter setting. The cutting blade, which is, you can see inside here. This is the cutting blade. You can see it glowing red. This is pneumatically operated, and it comes across very quick to cut this parison during the cycle. So it's set on medium. There's only 3 settings: low power, medium power, and high power. Or you can have cold if you want, off. So we will have medium. And we can set the number of cycles we want to run fully automatically on here. Just enter a particular, let's say 200, enter. And if we press reset, this will go to 0 when we switch on the motor. So that's this display screen. Timer settings. We have a mold closing delay time. On a fully automatic cycle, before the mold starts to close, there's a little delay time, perhaps half a second or 1 second. And then the mold goes up and closes around the parison, and then the cutter comes across. We can have a delay time for that, half a second or 1 second or no delay. The mold will go up, close, cut. Mold delay going down, blow pin, blowing delay time. That's for the blow pin going into the parison going down. The blow time, 21 seconds set here. Air pressure release time, 3 seconds before the mold opens. And then before the next cycle starts, we can set a particular cycle delay time, like 1 second. And alarm here, typical delay alarm messages, hydraulic pump. We haven't switched on the pump yet, so that's the error. So before we can run the molding cycle, we need to set the screw speeds, and we can set them on this central control unit. This is for one extruder, that's for another extruder, screw speeds. So for extruder number 1, we can set the speed on here. From experience, we can set it at 30 RPM. And for the other extruder, which is a smaller extruder, we can set that at 50 RPM. Now we can either leave it like that, or we can synchronize the speeds. Let's synchronize the speeds, so that if we change this on the master instrument, both will change at this ratio, 3:5. So now we can. Now we can set the settings on here. That's for the motor. We set this on fully automatic, and when the parison is at the suitable length, we only judge that by eye. When we think it's the right length to begin with, we press the start button. So this looks about right now. So now the mold is closing around the parison. Come down, the low pin has gone in, blowing at this pressure, and at the same time the parison is continuing to come down for the next cycle. So we just cooling now. Release the air pressure, mold opens, mold goes up to collect that extruding parison, cut, come down again, and cycle is repeated. So at this stage, the blow pin has gone down into the mold, into the parison, blowing the parison into a bubble. At the same time, parison is continuing to extrude, and the previously blown bubble is cooling on this support here. The air pressure is released, the mold opens, the old molding drops down, the mold goes up, closes around the parison, cuts the top off, pin down, blowing. So the bottle ideally should have a little bit flare on the top and a little bit of a tail at the bottom, and that's perfect. Mold open, go to the parison, cut off the top of the parison, lower down, blow pin in, blowing. When it's time for the blade to cut the parison, we close off the bottom with the mold and you'll see that it blows up a little bit of a bubble above the cutting blade there, and that gives that part of the parison some strength so that it's easy to cut. So we need some air to pass down through the die continuously, and that die, that air is controlled using this valve here. So you want to adjust it, you know, trial and error. It's only a very small amount of air. But if you don't blow air into the parison, it'll be kind of floppy and very difficult to cut. So the air blows up and gives it some strength so that it's easy to cut. Now the parison is coming down now. You can see it's coming down very straight and parallel. Sometimes the parison comes out and it comes out to one side, which indicates that the die gap is not even all around the center pin. So we need to adjust that, and that's the function of all of these screws going around the bottom of the die. So we have to loosen the screws on one side and screw in the screws on the other side so that we can move a ring, and you can see the way the parison comes out when you've got the right setting. So it should come out perfectly straight like that, vertically coming down, without what they call banana ring going to one side. So all the times and the screw speeds and so on are all done on a trial and error basis. If the tail part of the molding is too long, then we have to either speed up the cycle a little bit or slow down the extruder screws a little bit to make them shorter. But about 1 centimeter at the bottom of the bottle is perfect. And you can see the neck on the top. Now there's our molded bottle. It's got a tail and it's got, sometimes called ears, but it's got this piece at the top. These should be easy to remove, like this. Now this is more difficult to remove, which means that the end of the blow pin has not gone into the striker plate hard enough. So it's not cutting that off. No, it's very, very difficult to remove that. So to adjust that, we loosen those screws at the top, and we can screw the blow pin down a little and then tighten it up and check, again on a trial and error basis. We don't want the pin going into the striker plate too hard, otherwise it'll very quickly damage, put a ring on the striker plate. So what people do, they put a piece of paper in the mold opening and bring the pin down to the striker plate, and it should just separate, make a ring of the paper, very thin paper, like tissue paper. So here's our molded bottle with the top part and the bottom half removed, and we've cut a bottle through the center to show the thickness distribution of the two layers. And as you can see from here, I think, it's a very uniform thickness distribution of the yellow inner layer and the red outer layer. So you can see here that the parison is being extruded down. At the top of the die, this is the pipe and the air inlet for the air to pass through the center of the die. So when the mold goes up, it'll go around the parison, and you'll see above the cutting blade, it blows up before cutting. So that's why we need a little bit of air going through the die. So we'll get as you can see from here, with a very nice square cut, very even. Now for the extruders, we need to supply electrical power, and we also need a water supply, but only for cooling the part of the barrel under the hopper. That's these in and out cold water. The rest of the barrel, of course, are cooled by the air blowers. And for the blow molding attachment, we need power again and compressed air supply for blowing the bubble and operating the cutting knife. And for water, we need some water supply for cooling the mold. That can either be water at room temperature or ambient temperature, or you can couple it up to a chiller if needed. So we need water for the mold. Normally that's run at a fairly low temperature, because this is what determines the length of the cycle time, really. The machine is cycling now and making bottles. If we open the door, we'll see that the cycle stops, because the opening the door has cut off the hydraulics. The mold continues to open a little bit, but otherwise the cycle has been interrupted.